Hello and welcome to another walkthrough video of IAL Edexcel AS Level Physics, and today we are going to do the walkthrough of October 2025 Unit 1 exam, and it will be helpful for your upcoming exam in 2 weeks for Jan 2026. And this paper has some really tricky questions, so I will recommend you to watch this video all through. And if you need any help in physics, just let me know, and you can contact me on the given numbers on the left hand side of this video. And I'll be very happy to help you and can also be your personal tutor. Okay, question number one. Which of the following is a unit for a vector quantity? So you know that joule is the unit for energy, which is scalar. Kg is the unit for mass, which is scalar. Watt is the unit for power, which is scalar. So the only quantity vector is force. Question number two. A lamp has a constant power input and a constant efficiency. Which row of the table describes how the useful power output and the total energy output vary with time? So first of all, efficiency formula is output power over input power. Okay. And they're talking about total energy output and efficiency. Okay. So, um, so total output power is equals to efficiency times input power. Okay. All right. So they're telling you that you have the constant input power and the constant efficiency. Okay, so this is constant and this is constant. So it means that this whole thing is constant. So now output power is what? Output power is energy over time. Okay, and this is something is output energy, and time will go there. And now you know that the time elapsed, it keep on increasing, increasing, and increasing. It never stops. So when the time is increasing, the energy output is also increasing. Okay, that means the power is actually the rate of consumption of energy that never changes, but the total energy that is actually changing. If just like take yourself, you can eat like a constant amount of meal in a day. You cannot eat more than that. I mean, you have the rate of consumption is like constant, just like for a car. No, the car has a constant energy consumption rate. For example, like it runs 20 kilometers for 1 liter of oil. So everything has a constant rate of consumption of energy. That is called power, because power is energy over time. Rate of consumption of energy is called power. So power is always constant for anything, because a bulb, engine, gadget, it always consumes power at a constant rate. Okay. So that is always constant, whereas the energy output is keep on increasing if you're using it for like extended time. Therefore, the option for this question is B. Which of the following is always true of the forces in a Newton's third law pair? So Newton's third law pair has four conditions. Number one, there must be two bodies. Number two, the two forces must be equal in opposite direction. Number three, and the nature of the forces should be same. And the number four is the two forces act on each other. I mean, first object will put force on the second one, and the second object will put force on the first one. So under these conditions, only option is D, because you cannot put the forces on the same object. This will violate Newton's third law of motion, and they cannot be in the same direction. This will violate Newton's third law of motion, and the forces cannot cause acceleration because these two forces are equal in opposite direction, so they will cancel each other and there will be no acceleration. So the only option for this is D. Hmm. A ball bearing falls through oil at terminal velocity. So terminal velocity means when upward forces are equals to downward forces. Okay, remember that. And if this is the object, this is the ball bearing falling, this is like oil. Okay, so we can say that the weight is acting downward and upthrust and drag is moving upward, acting upward. Okay, so my equation will be upthrust plus drag equals weight. This is my equation. Now, you know that when temperature is decreasing, as they are saying, which row of the table is correct when the temperature of the oil decreases? So when temperature goes down, density goes up because the molecules comes close to each other, and then density increases. And when the density increases, you know that the upthrust is rho Vg. So upthrust rises. So when the upthrust rises, it means that the drag and upthrust will take less time to get balanced with weight. And if the ball is having less time to travel and the sum of forces quickly become equal to each other, then the ball will not be able to gain more and more speed, because the sooner the sum of the forces on it becomes equal, the quicker you will have the terminal velocity achieved. So if the forces becomes equal to each other quickly, it means the ball will get only small amount of time for the acceleration. Therefore, the terminal velocity will be very, very small. Okay, I'm giving you an example. For example, initially upthrust was 1, drag was 1, and the weight was 5. Okay, so, uh, as the body started to travel, upthrust was keep on 1, but because the body is increasing the speed, and you know that the drag force Ft is 6 pi r eta v, so we know that the drag force is directly proportional to the speed. So, as the body is gaining speed, the drag force is turning into 2, 3, and 4. As soon as the drag force turns into 4, so 4 plus 1, 5. 4 plus 1 equals 5. That is the point when we will say that the body gained terminal speed. So, as long as the forces are not balanced, the body or the ball will keep on accelerating. The ball bearing will keep on accelerating, or the speed will keep on rising. However, for example, if I say that the density is now decreased because the molecules are close to each other, so I'll say that the drag started from 3 directly, for example, and the upthrust is still 1 and the weight is 5. So it will be just take a small amount of time to get to 4, and the 4 plus 1 will become 5. So as soon as these forces become equal to each other, the body will gain a very small speed, and that small speed will remain constant because the sum of forces are gone, so there is no force there more to accelerate or decelerate the body. Therefore, the speed will remain constant. So the only option is C, because viscosity increased means drag force increased. Okay, 6 pi r eta v. So when you increase the drag, it means you are increasing the viscosity. Viscosity is a direct measure of the density. As you have more density, it means you have more viscosity or more viscous drag. Okay, and therefore the terminal velocity will decrease. A balloon moves upward at terminal velocity. The forces acting on the balloon are upthrust, viscous drag, and W. Which of the following statement about the magnitudes of the forces acting on the balloon is correct? It's quite straightforward. As the balloon is moving upward, it means the upthrust is greater than weight, because if this is balloon, so upthrust is on acting upward and the weight is acting downward. And since the drag is always opposite to the direction of motion, so you will have this equation, weight plus drag. And from here, since the weight of the balloon is negligible, so you only have this kind of equation. Okay. Weight or drag, like this. A plank of wood has weight W. The plank rests on two supports. The forces from the supports on the plank are FA and FB. Which of the following vector quantities give the relationship between FA, FB, and FW? Well, this is a tricky question. Here, this arrow shows vectors, not the magnitude. It is a total full-fledged vector. So since the acceleration here is zero and the plank is not moving, it means the sum of forces acting on the object is zero. So you just need to write FA, FB, and W equals zero. Okay. Because the W has I mean, the negative direction actually is written when we are just writing up the scalar quantities or their numbers. Okay. However, here there are these are not scalar quantities. We are just mentioning up all the vectors, and the sum of vectors should be zero. If we write FA plus FB minus W, it means that we are not taking vectors like this. Rather, we are taking vectors like this: FA, FB, and minus W. Okay, which can never be zero. Therefore, the option is D. A student uses a piece of string to attach the mass of 0.4 kg to mass of 0.5 kg. She then places the string over a pulley as shown. Which of the following gives the acceleration of 0.5 kg mass in meter per second square? Okay, so uh, for 0.4 kg mass, we know that the tension is moving upward, whereas the weight is acting downwards. Okay, so we have to consider the two masses separately. For 0.4 kg, first of all, you will write for 0.4 kg, what is the net force? The net force is tension. Tension has to be positive because it is a winning force, because the mass 0.4 g will go up. Since 0.5 kg is more, so 0.5 kg will move down, whereas 0.4 kg will move up. So the winning force has to be positive and the losing force, which is weight, has to be negative. Okay, it is always true for any scenario in physics. And now from here, the acceleration will be ma, the tension is T, and the weight is simply going to be mg, which is 0.4 times 9.8 or g. Okay. Okay. So from here, my tension is 0.4 times a minus 0.4 times g. Okay, this is my equation number one. Now I am going to do the same for 0.5 kg mass. And for 0.5 kg mass, F net is equals to W minus T, because here the weight is acting downward. It means weight is the winning force, whereas the tension is losing force. Therefore, we are going to write W minus T, and same is the case here. We are going to write FA, then mg minus T, and from here T is mg minus ma, and T is equals to m is 0.5, g minus 0.5 a. Okay, so this is my equation number two. Now, the left hand side of the equation 1 and equation 2 is tension. So we can compare 1 and 2. Compare 1 and 2. So when you compare 1 and 2, the left hand sides are equal. So the right hand sides will become equal as well. 0.5 g minus 0.5 a. So from here, I'm going to find out the value for the acceleration, which will be 0.4 a plus 0.5 a equals 0.5 g plus 0.4 g. Okay, I'm just rearranging, and from here the acceleration will be 0.4 plus 0.5 equal, from here the acceleration is uh, this will go that way. Okay, so 0.4 plus 0.5 g. Okay, from here the answer is going to be, there is a kind of a negative mistake I did, I believe. Let me check where the mistake is done. Mm, oh yeah, I believe it has to be positive. Apologies. And I believe that is it. Yeah, it has to be this. And when it goes that way, it has to be negative. Yeah, okay. Okay. Oh yeah, sorry, 0. Oh yeah, that's true. Okay. So now you just need to rearrange, and when I'm rearranging, the answer is 0.4 g minus 0.4 g. Okay. And from here, 0.5 minus 0.4 g, and from here the answer is going to be 0.5 minus 0.4 to 9.8 divided by 0.4 plus 0.5. Oh, it was a very lengthy question. Therefore, the answer to this is going to be B. Okay. Yeah. Okay. A student uses a piece of string to attach mass of 0.4 kg to a mass of 0.5 kg. She then places the string over a pulley as shown. Which of the following gives the acceleration of the 0.5 kg mass in meter per second? So we need to find out the acceleration for the mass of 0.5 seconds. So first of all, you should know that the whatever the acceleration is here, the same acceleration will be here. Okay, so the acceleration is same. And secondly, because the 0.5 kg mass is more, so this body is going down and 0.4 kg body is moving up. Okay, and thirdly, there is a tension in the string, and both tensions are moving upward. Okay, so I have to do some calculation for this question. For first of all, for 0.4 kg mass, and for 4 kg mass, you need to see how much are the net forces acting on the 0.4 kg. There is a weight acting downward and the tension upward. Since the 0.4 kg mass is moving upward, so the tension is winning. Tension is the winning force. It is taking the mass upward, and weight is losing force. It is unable to move the weight downward. Okay, so from here, acceleration is mg and t minus w, and from here, t is ma plus w. Okay, and from here the answer is going to be uh, just put the mass 0.4 A plus 0.4 G. Okay, this is equation number 1. Then for 0.5 kg, for 0.5 kg, again you will apply F net. F net is now W minus T because 0.5 kg mass is going down. So weight is the winning force, tension is the losing force, it is negative. So MA equals mg minus T. So rearranging it will give us mg minus MA. And from here, you are just putting the masses 0.5 g minus 0.5 a. Okay, this is 2. Now you can see that the equation 1 and 2 has tension on the left hand side, so you can compare them and eliminate the tension. So just comparing and writing it, 0.4 a plus 0.4 g equals 0.5 g minus 0.5 a. Okay, now you need to find out the acceleration. Therefore, you are bringing the acceleration on the one hand side and the gravitational accelerations on the other side. So from here, 0.4a plus 0.5a equals 0.5 g minus 0.4 g. Okay, so acceleration here is 0.4 plus 0.5, and gravitational acceleration here is 0.5 minus 0.4 g. From here, acceleration value is 0.5 minus 0.4 into 9.8 divided by 0.4 plus 0.5. So this option is looking like B. The table shows information about two wires made from different metals. A tensile force applied to produce an extension delta X. The same tensile force is applied to Q. Which of the following is the extension of Q? Okay, so since it is given Young modulus, so first of all, we have to calculate the extension for wire P. Okay, so we know that the Young modulus is actually equals to stress over strain, and stress is force over area divided by the strain is change in length over original length. Okay, so summarizing it, we are going to get fxa delta x. Okay, so from here the extension will be fxa e. That is for P. Okay, now what about Q? When you talk about Q, you don't have the um, force, I mean the Young modulus as 2e, and the area is a by 2. Okay, so you are going to write it as it is. So you are just putting area as a half area and Young modulus as 2e. So this 2 got cancelled with 2. So again, you got the same extension as you have for P. Therefore, Q and P will have the same kind of extension. Therefore, you have to say that the answer to this question is C. Okay. As you can see the mark scheme, it is C. Okay. So question number 9. The acceleration time graph for the motion of an object is shown. Which of the following could be the displacement time graph for the motion of the object? Okay. Uh, okay. So in the first graph, the displacement is decreasing. So when the displacement is decreasing, your velocity is actually decreasing, which is not true because here, uh, because if you see that the acceleration is constant, which means the velocity is rising rather decreasing. Okay. Then the displacement time graph here, this constant curve, because it is displacement versus time, so velocity is the gradient of this and the velocity is constant here. Here the velocity was decreasing, okay, which is not true. When acceleration is constant means velocity is continuously increasing at a constant rate. So here velocity is constant, which is also not possible. Then displacement is curved, okay, this shows the velocity is increasing, but what about this one? This one shows that the velocity got zero all of a sudden. The acceleration, the displacement becomes a constant line, so here the velocity is zero because it becomes constant, so the gradient will be constant. So that is also not true because acceleration zero means the body is still moving at a constant speed. So there should be a displacement keep on going that way. Okay, but at a constant speed, not like shaky, but at a straight line like this. Okay, so here the straight displacement line means the velocity is zero because the gradient of this line will be zero. So which is not true as well. And after eliminating all answers, our answer is D. So this part is showing you when acceleration is zero means body is moving at a constant speed. So constant speed graph or the constant speed velocity time, you see, this is the graph. And for this velocity time graph, you have displacement time graph like this, which is given exactly like here. And this part is actually showing you the increasing speed at a constant speed. So this is like a parabola. Okay. It looks like a parabola, and remember that when the body has a constant acceleration, its speed is rising, and when its speed is rising, the displacement time graph is always parabolic. Okay. When you have constant acceleration and the speed is rising constantly, okay, then you have the displacement time graph like this. Remember this. So the only option for this question is D. Two objects R and S are falling vertically and accelerating due to gravity. A resistance is negligible. R has mass m and S has mass 2m. Initially, each object has momentum p. After time t, the object R has momentum 2p. Which of the following gives the momentum of the object S after time t? Very important question and very conceptual. Please remember that the momentum is the product of mass and velocity. Okay, so initially R has mass m and S has 2m. So if I talk about R, for R you have the momentum p because both have initial momentum v, and for S you cannot have momentum mass and 2v because the body has momentum 2m, so its speed must be v by 2. Okay, so initially initially the object S has half of the speed as compared with object R. Okay. After time t, this is initial. Okay. And after time t, the object R has a momentum of 2p. So, So, if you can see here that the bodies are falling vertically. So when they are falling vertically, they are having a gravitational acceleration, right? So gravitational acceleration is independent of mass. So whatever the speed is actually equals to gt, because gravitational acceleration is velocity over time, and from here whatever acceleration is rate of change of speed, right? V over t. So if here the gravitational acceleration, so we can write v equals gt, and that is same for r and same for s, because both are falling vertically. So uh, for r and for s same, because the gravitational acceleration is same. Okay, now that is the speed which has been added into the given speed. So you can say this is v and this is v. Okay. So for p, sorry, for r, the speed becomes v plus v. It is becomes 2v. So 2v into mass, it becomes 2p, right? And for s, the speed was previously v by 2 and now it is v, just added because vertically moving, so then speed increased, and the final speed is 3 by 2, and the mass, this is the speed, and if you multiply it with mass, which is 2m, you get 3mv, and 3mv means 3p. Therefore the option for the momentum for object s is 3p. Question number 11. A lorry has a mass of 4500 kg. Okay. The forward force on the lorry is 700 and the resistive force on the lorry is 900. Calculate the acceleration of the lorry. Again, you can see that there are two or more than two forces acting on the object. And if the object is accelerating, it means there are some net forces acting on the object. So net force is actually equals to forward minus backward. Okay. So MA here, forward force is actually of 6700, backward is 900, and the acceleration is what you need to find. 6700 minus 900 over 4500 equals 1.28 meter per second. But be careful here. You can see that your data is given in almost two significant figures. So your answer should be having two significant figures, not three significant figures. Therefore, you have to round it off to 1.3 meter per second. I have seen Edexcel cutting off so many marks of the students just because of the significant figures. And they don't mention it. They just detect marks silently. So be careful with that, okay? The key is whatever the significant figures you have in your data set, write the same number of significant figures in your answer. For example, mass is given two significant figures and you are finding out the mass. So you need to write the answer of mass in two significant figures only. However, if time is given in three significant figures and you are measuring the time, your answer should also be in three significant figures. A sailing boat is moving through water. The force of the wind on the boat is 350 Newton towards north. The force of the water on the boat is 410 Newton at an angle of 120 from the north. As shown, determine the magnitude and the direction of the resultant force on the boat using scaled vector diagram. Okay, so here you need to draw the vectors. First of all, because you have a large space, so I'll try to use all of the space. Okay, first of all, this vector. Okay, and because this is the first vector and the second vector has to be head to tail, you need to know the head to tail rule. In the head to tail rule, the head of first vector is connected with the tail of second vector, and the second vector will be drawn as it is, okay, like that. And this is actually showing off 410 Newton, and this is actually showing off 350 Newton. This is the first vector, and the head of first, which is this, is connected, head of first is connected with the tail of second vector. And if there would be any third vector, it should have been connected with head of second to the third, tail of third, and so on. And when you have done all that, without changing the shape, without changing the orientation, without changing the direction, just copy the vectors as it is. Okay, let me show you what I'm actually doing here. So for example, this is the vector. Okay, I'm making the vectors big for you. For example, one is this vector and one is this vector. Okay, so how do you apply head to tail rule? You just take out the vectors here. First of all, you shift the vector here. Okay, maybe here, and then connect the head with the tail of second vector as it is. Now the resultant vector will be in blue, and it starts from tail of first all the way to the head of last. Okay, so this is the 350 Newton, this is 410 Newton, and when I have to mention up the scale, so I use the scale as 1 centimeter as 50 Newton, and this side should be 7 meter, and this side should be 8.2 centimeter, and the resultant was about which what I have measured. It was 7.5 meters. Okay, 7.5 centimeter. That shows around um, 375 newtons. Okay, so acceptable answer range in the mark scheme was 370 to 390. Okay, and the angle was 68. Okay, and this angle was 56 degree at as it is given in the, sorry, 60 degree as it is given in the diagram above. Yeah, yeah, because if 120 is outward, so this angle should be 60. So this angle should be 120 and this angle should be 60. Okay. 13. A student used two different methods to investigate the acceleration of a freely falling object. In the first method, the student dropped a ball from a rest um, at a known height. He used a stopwatch to measure the time taken for the ball to reach the ground. He repeated this several times. He then calculated the mean acceleration of the ball. Explain why there was a large uncertainty in the calculated value of the acceleration. Of course, when you are pressing up the stopwatch and stopping down the stopwatch, you have some kind of reaction time. Some children will do it quickly, some children will do it late, some children will do it precisely, some children will do it with some mistakes. So therefore, you have to say that the there will be like a big human error in the measurement of time. Okay, there will be error in measurement of time due to reaction time of student. And if you apply the SUET, ut plus half gt square, initially the speed is 0. So from here, the gravitational acceleration becomes 2s over t square. So you can easily see that um, the 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 error in the time measurement is like, if it is big, the value of the gravitational acceleration is going to be changed a lot. Okay, so when you repeat your measurements and every time you have different result, that is called random error. Okay, so because of reaction time or because of wrong measurement of time, you will add up random error. Random error will increase. So systematic error means any error because of the system failure or your instrument failure. But random error means every time you're doing the same way and you're every time you're having different measurements or answers, it means there is something wrong that you're not getting it. So it is like kind of a random kind of error. So random error will increase if we don't fix the reaction time of student. Okay. In the second method, the student positioned light gates near the top and bottom of the transparent vertical tube. He dropped a metal cylinder into the tube as shown. The time taken for the metal cylinder to pass through each light gate was recorded by a data logger. The student measured the distance between the light gates, gave one other measurement needed to determine um, the acceleration of the metal cylinder. So as I have mentioned in the previous part of this question, this time, I mean from here to here, the calculation of time will be done by the data logger. Okay, by the data logger or whatever he applied by the gates. But this distance, you must have to put that in this formula and get G. So you'll just say the length of mm, cylinder. Okay, or you can say the distance between the two gates. The speed of the metal cylinder through the first light gate was 1.39. So this is U. The speed of the metal cylinder through the second light gate was 2.96. This is V. The distance between the light gate was 355 millimeter. This is S. Calculate the acceleration. So you can easily apply the third SUAT. V square equals U square since the body is moving down. So gravitational acceleration is positive. 2.96 equals 1.39 square plus 2 into 9.8 into S. And from here, the S is going to be 9.62. Now you can see that our data is in three significant figures. So I am writing the answer in three significant figures as well. Two rocks in outer space are moving at different speeds along the same path. State the principle of conservation of momentum for an isolated system. This is 1 mark for an isolated system. That means there are no external forces acting. The total momentum of the system is conserved. Okay. The total momentum of the system is conserved. Okay. Rock A has a mass of 43 kg and a velocity of 7.8 meter per second. Rock B has a mass of 56 kg and moves in the same direction as rock A. The kinetic energy of rock B is 4.1 into 10 raised to the power 3 joule. Rock B collides with rock A. After the collision, rock B continues to move in the same direction with a momentum of 530 kg. Calculate the new velocity of rock A. So first of all, you will write initial momentum equal final momentum. Okay, because law of conservation of momentum says initial momentums is the sum of initial momentum equal to the sum of final momentum, or the total momentum remains constant. So initially rock A, I mean the body A, has a momentum of 43 times 7.8. This is the part A. And for the part B, it is moving with some speed 56 times u. So it is initial speed, we don't know. And after collision, they're saying that the rock B has a momentum of 530. Okay. So for the A, um, for A, it will be 43 into V, that is for A. And for B, it is already given as 530, so we don't need to write mass into velocity. So that was the initial momentum of A, that was the initial momentum of B, and that is the final momentum of A, and that is the final momentum of B. Okay, so the energy of the second, the second object is already given to us. Okay. So you will use KE to measure the initial speed of B. Okay. So from here, you know that the kinetic energy for B is given as 4.1 into 10 raised to the power 3. So you will just write half mv square, rather V, you just write U square, 4.1 into 10 raised to the power 3. So from here, U square will be 2 into mass. Mass of the second object is 56 times 4.1 into 10 raised to the power 3. And from here, the initial speed value for B is 12.1 meter per second. Okay. And finally, you can easily get the speed as it is mentioned here. So what you are going to do now, I'm just multiplying everything. So 335.4 plus 56 into 12.1. I'm multiplying this and now putting this here, equals 43V plus 530. Okay. So after summarization, my answer is going to be 11.2 meter per second. But again, you should be very much careful that your data is in two significant figures, especially for the velocity. So it should be in two significant figures only. You have to round it off to two significant figures. Okay. Question number 15. A student investigated a spring. The student measured the unstretched length of the spring. The student suspended different objects from the spring as shown. She measured the new length of the spring each time. The unstretched length of the spring was 0.250 meters. The When the ball was suspended from the spring, the length of the spring was 0.295. Okay. When the 200-gram mass was suspended from the spring, the length of the spring was 0.375. Calculate the weight of the ball. Okay, very easy question, not that difficult. So initially, you have the length of the spring as Li as 0.250 m, and the final becomes 0.29295 meters. Okay, and that is for a ball, not for the what the mass. Okay, and from here the extension is 0.295 minus 0.250 equals 0.045 meters. Then for the hanging mass, the initial one is 0.250 meter and the final one is 0.375 meters. So that is for the mass hanging, or okay. And for that, the change in length is how much? The change in length is, you just need to subtract 0.125 meters. Okay. Now they're asking you to calculate the weight of the ball. So you know that this is the extension and spring constant. So we are applying Hooke's law. Okay. And we are applying Hooke's law initially for the 200-gram mass. Okay. F equals MA. So M will be 0.2 because 200-gram is converted into meters, and G is 9.8 equals K, and delta X is 0.125. So from here the value of K is 15.68 Newton per meter. Okay, now for ball. For ball weight, we will just write F equals K delta X. So from here, mg or W, because the force here now acting as weight, and the answer to this is 15.68, and the extension is 0.045. Already we have concluded that, and the answer is 0.706 Newton. Now you can see that the data is in three significant figures. Can you see? So our answer is also in three significant figures. Okay. The sketch graph shows how the extension delta x of the spring varies with total force F on the spring. Explain why the elastic strain energy stored by the spring is proportional to F square. Well, this is a mathematical question. You know that F is equals to K delta X, correct? So from here, you also know that the elastic strain energy is equals to half uh, base into height, because area under the forced extension graph, it gives energy. Okay, so half base into height, elastic strain energy equals uh, half into F into delta X. Now F is actually not a problem, rather delta X, and for delta X we are going to put F over K, because F equals Kx. Okay, so from here elastic strain energy, you can easily see that it is going to be F square. Okay, so from here we can say that ESE is directly proportional to X square. Okay, question number 16. The paragraph shows an athlete using a running blade. The value of the Young modulus for the material used to make the running blade is 19 GPa. State which property of the material relates to the Young modulus. Okay, Young modulus is a number that tells you how hard or how soft a metal or material is. So, which we call that word as stiffness. Okay, so metals are greatly stiffed, so their stiffness number is bigger than the plastic or rubber. Okay, therefore, um, we say that the Young modulus is the measure of the stiffness. Okay, so you are going to write stiffness only. Okay, a sample of material has a length of 0.50 meter. In the laboratory test, a compressive test of 150 megapascal is applied to the sample. The sample deforms elastically. It is compression, remember, and it is important. Okay, determine the new length of the sample. Oh, oh, नींद आ रही है, क्या करूं? ड्यूटी भी पूरी करनी है. All right, so you are going to write the formula for the Young modulus, and the formula for the Young modulus is, uh, let me write it down here. Here. Okay, so Young modulus which is given to you is 19 gigapascal, right? So you are going to write 19 into 10 raised to the power 9 pascals. Okay, and the given stress is how much is the given? 150. Okay, 150 megapascals. So you can write 10 raised to the power 6 pascals. All right, and the length of the material is 0.450 meters. Rather, you may write x. Okay, and you need to find out the new length. So this is the initial length, and you need to measure the final length. So first of all, writing the Young modulus formula, E equals Fx over A delta x. Okay, and my apology, not like this one. We need to write stress over strain. So E is strain from here is equals to stress over E. Okay, so stress is 150 10 raised to the power 6 over 19 into 10 raised to the power 9. Okay. So strain is change in length over original length. From here, it is 150 into 10 raised to the power 6 divided by 19 into 10 raised to the power 9. Original length was mentioned as 0.450 m, and when we measured the change in length, it was about 3.55, as the given data is in three significant figures. So our answer is also in three significant figures. Now, this change in length is actually equals to final length minus initial length. Okay, so 3.55 into 10 raised to the power minus 3 meters, and from here the final length will be xi plus 3.55 into 10 raised to the power minus 3. Xf is going to be so our answer is going to be okay. Now here the trick comes. When we do the compression, the final length is smaller and the initial length is bigger, because the word uh, uh, mentioned here is compression. Okay, so for that we rather put uh, you can say here not plus, rather subtraction. Okay, so uh, there has to be a plus. So because of the final length, you are just subtracting. You are subtracting 0.450. Okay. So when you're subtracting it, you are going to get the answer as 0.446. So what you need to remember for extension, this is final minus initial. Okay. So for extension, you may write plus, and for the compression, you need to write a minus. Okay, be careful with that. So your answer should be in three significant figures as well, because our data in the question is in three significant figures. B. The running blade is made from a single material. The table shows the compressive breaking stress of the three materials used to make the different running blades. The cross-sectional area of the running blade is 8.5 centimeters square. The maximum compressive force that can be applied to the running blade before it breaks is 330 kilonewton. Determine which material the running blade is made from. I believe it's a very easy question. So we just need to find out the breaking stress. F over A. You have already the values for the and this one 8.5 times 2 is not 4. Okay, so answer to this is 388 megapascals. And since our data has only two or three significant figures, so two or one significant figure, so we can write the answer in maximum two significant figure. Therefore, I'm bringing it to 400 megapascals. Okay, yeah, that is true. Okay, so this 400 is actually belongs to carbon fiber. We have to mention that the fiber was carbon. Okay. Question number 17. A lifting bag is a bag that can be filled with air and used to lift heavy objects from the bottom of the sea. Lifting bags are attached to an object and then filled with air. A person attaches two spherical lifting bags to a box at the bottom of the sea as shown. The total weight of the box and the two lifting bags filled with air is 2500 Newton. The diameter of the each spherical lifting bag is 50 centimeter. Deduce whether the object will lift from the bottom of the sea. Density of the water is 1020. Okay. So you know that when anything is under the water, upthrust applies only on its volume. Okay. So it will be applied nowhere else rather the um, ropes or the body size and shape. That's it. Okay. So They're saying deduce whether the box will be able to lift from the bottom of the sea. Okay, so since okay, assume that the object is receiving the objects from the sea. For example, our geologists or um, anyone says that the object is moving up. So when the object is moving up, it means there is a net force acting on the body. And when there is net force acting on the body, upthrust is winning because it is positive, and the um, weight and drag is losing. Okay, because the object is moving up. Okay. Initially, you can say that the velocity is zero. So velocity is zero, so drag is also zero. So what we are left with, we are left with F net equals ut minus W. Okay. So what is ut? The weight is 2500 because it is the weight of the total bag. Okay. And now we are going to calculate the value for the ut. So for ut, we know that calculate now ut. For ut, you know that it is equals to rho v and g. Okay. So just put the values. Ut equals the given density of water, which is 1020, the volume, which is uh, this object, this one, and this one. So two spheres and one cube. So you are going to write uh, thrust is like V of spheres plus cube. Okay. And now because the spheres are spherical, so we have to multiply them. We have to find the volume by length into width into height for cube and 4 over 3 pi r cube for the balloon, so for the spheres. So ut is 1020 and 2 into 4 over 3 pi r cube pi r cube. The cube is 0.25. Okay. And okay. And the radius that is given is 25 centimeter. So 0.25 cube. Okay. 2 4 over 3 pi r cube. And then plus That's it. And plus 0.10 into 1 into 0.5 into 0.25. Okay. So when we multiply all them together, our answer is going to be 2700. Okay. So why I waited till the last of this question? The F net is 2700 minus, so equals F net is 200. So yes, boss will be lifted because the upthrust is more by 200. So lifted. Okay. As the person filled the lifting bag, small bubble of air escaped and moved through the seawater. Calculate the terminal velocity of the bubble of air predicted by Stokes' law. Okay. So Stokes' law is F equals 6 pi r eta v, right? So the weight of the air bubble is 1.82 times 10 raised to the power minus 6. Okay. The upthrust is this, and the viscosity of seawater is this. Okay. Okay, so this is the drag, and the upthrust is also given. And I'm going to write the formula for the um, total uh, force on the total force on the bubble is, since the bubble is moving up, so upthrust is dominant. The weight is acting downward and the drag is also acting downward, so that they have to be negative because they are losing one. The upthrust is the winning one. Okay, but you know that the I mean the so because of the terminal velocity, you know the sum of forces acting on the object is zero, acceleration is zero here. Okay, so you are going to put zero here. Okay, okay. So from here up t equals w plus d. All right, and from here up t minus w equals t is 6 pi r eta v. So just putting up the values. Upthrust given here as 4.77 into 10 raised to the power minus 4. Weight is 2.25 into 10 raised to the power minus 3 divided by 6 pi, or the radius of the oval is uh oh, this is not radius, this is not weight, this is radius, so weight is 1.82 into 10 raised to the power minus 6. 6 by r is 2.25 into 10 raised to the power minus 3. 6 by r, and eta is 8.6 into 10 raised to the power minus 4. All this is equals to Vt. And from here, Vt, the terminal velocity, is 13.02 meter per second. There is something wrong with my pen. That is the answer to the question. Give two reasons why the terminal velocity of the oval may be different from the value predicted by Stokes' law. So you know that in the sea, the 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 seabed is very cold, whereas the surface is hot. I mean the moderate temperature. So it means the temperature is varying. It means density is varying. When density is varying, means upthrust is varying. When upthrust is varying, means the flow may not remain laminar, right? Because the water can get rough, right? So you can say, let me type it because um, my pen is not working good enough. So let me type it here. the bubble may not have laminar flow as Stokes law only applicable on laminar flow. Number one, okay. Number two is the temperature may change as bubble moves up, due to which the density changes and drag force also changes. So it cannot remain constant throughout, okay? Yeah. So question number 18.